Well, here we are. We begin now really the next phase of the course. We've talked about derivatives and we've talked about applications of derivatives. Now, we're actually going to go the other direction. In other words, instead of me giving you a function and you giving me a derivative, which is a very important skill, don't get me wrong. When in doubt, take a derivative. I'm going to give you a derivative and you give me a function. And then we'll talk about the applications of all that. But how might we do that? Let's take a look. Let's say we're going to take the derivative of these three functions. Okay? Not so bad, right? Now, I know what you're thinking. Typical teacher, right? You're going to give us an easy problem in the description and then give us really hard ones for homework. And you're right. That's exactly what I'm going to do. But I'm trying to give you an easy one so sort of you can understand the big picture. Okay? What's the derivative of each of these? So what do we do? And this is really important, so stay with me. We say dy dx equals 2x, right? How about the next one? dy dx. What's happening? All of these functions have the same derivative. So if I were to say, okay, 2x is the derivative of what function? Well, you could give me an infinite number of functions, couldn't you? And that's what we're going to be talking about. So instead of going from the function to the derivative, we want to go from the derivative to the function. The word we're going to use is antiderivative. Pretty self-explanatory. So if I say dy dx equals 2x, you might say, okay, that means that dy equals 2x dx, and you'd be correct. Now, we undo the derivative. So just like when we took the derivative here, we said, okay, y, take the derivative, that means you have dy dx. Here, when I have dy equals this, I'm going to say, okay, y equals, well, x squared. But now, what is it? Is it x squared plus 7, x squared minus 2, x squared plus 5, x squared minus pi over 4? I don't know. So what do? We write plus c, where c is any constant. So we don't know. So in other words, this is a family of functions. And that's the idea here, right? A function has one derivative, but a derivative can go with an entire family of functions. And so that's how I want you to think about it, okay? Family of functions, x squared plus c. So basically, what we have is, you remember how you have all the derivative formulas? Well, we have antiderivative formulas. And it's just that they all end with a plus c. What does that look like? Well, I'll show you. Remember our notation. Little f prime, big F, right? Derivative antiderivative. So we know that little f prime is the derivative of f. The big thing you need to learn today and to get through your p-brains is that big F prime is little f. And that's what you got to remember. We call big F the antiderivative of little f. Let's write that down. Big F is the antiderivative of little f. And unless we know a point on little f, big F always has a plus c on it. So let's take a look at how this works in action. Okay, so again, the concept, this is not a, I don't want this to be a complicated concept for you, right? Because what have you spent the first part of the course doing? I give you a function, you give me a derivative, right? No problem, everybody can do that. Because what have you done? You've learned your derivative formulas, right? If I give you big F, and I tell you big F is sine x, you tell me little f is cos x, don't you? Right? But what if I tell you little f is cos x? Big F is going to be sine x plus some constant. So it was really plus some constant, wasn't it? In fact, that's what you should have said 2 months ago. You should have said, wait a minute. Couldn't you say sine x plus c? Because it could be a constant, because the derivative of a constant is 0. That's what you should have said. But hey, it's okay. I'll let it slide. How about here? So we knew that cos x plus c gave us negative sine x. But what would give us sine x? Negative cos x plus c. And then you have a whole list of formulas here, which I'm sure you could, sort of flip around in your brain, right? Here's the big one that students need to know in introductory calculus. You all know that if I give you x to the n, and now we're going to say x to the n plus c, right? The derivative is going to be n x n minus 1. Right? No problem. I know what you're thinking now. I know all this. You're wasting my time and money. But what if I put the x to the n here? What would you put over here? Let's think about that. You've got, what's the exponent difference? Well, the exponent in this column is 1 less than the exponent in this column, right, for a polynomial. So that's going to be x to the n plus 1. But if I take the derivative of x to the n plus 1, I have n plus 1 x to the n. But I don't have an n plus 1 over here, do I? So let's divide by n plus 1. We'll throw on a c because we're good students. But think about that now. If you take this derivative, what happens? Well, you have n plus 1 x to the n plus 1 minus 1 divided by, still, the n plus 1. And look what happens. The n plus 1's cancel, x to the n. Isn't that pretty cool? Isn't that pretty cool? How about a constant? If I had n here, you had nx plus c here, right? Isn't that cool? And so that's kind of how that works. All right, so this is the idea behind the antiderivative. Now, what are we going to do? Well, we're going to learn a lot more about this in about a week, and we're going to use a word, integral. But for now, let's just stick with the word antiderivative. And let's deal with the c. And let me show you one problem that deals with the c. Okay? So it might be something like this. I might say, okay, here's a dy dx. Here's a derivative for you. This is going to be our friend. X squared plus 2x plus 1. 2x plus 1. Now, the y that goes with this is going to be a plus c. But I'm going to tell you that 3 comma negative 1 is on the graph of y. Okay, so let's see. How does that help us? Well, that narrows it down, right? All those plus c's, it narrows it down if you know a point on the actual graph, right? You don't have to write this down, but just think about it for a second. Think about y prime is 2x. That means y is x squared plus some constant, right? So that means you've got x squared plus something, x squared plus something, x squared minus. All of these graphs, all those vertexes are at 0, so x equals 0, by the way. All those graphs have that same derivative, right? But if I told you that the point 2 comma 5, then you know it's x squared plus 1. Okay, so let's do this problem. So we know that dy is x squared plus 2x plus 1 dx. All right, and then let's just go piecemeal. What is the function whose derivative is x squared? Okay. Now, the nice thing about this is we can keep this little formula right at our fingertips. Now, to be honest, it's kind of like tying a shoe. Eventually, you're going to stop watching the videos on how to tie a shoe and you're just going to know how to do it yourself, right? Even though I know when you first learn to tie a shoe, you got to watch a video. But you're going to get so good at it, you're going to do it so often, you won't need the video anymore. X squared, that's x cubed over 3. How about 2x? That's our friend again. How about 1? What is the function whose derivative is 1? So that's what you're asking yourself. You're saying, okay, what is the function whose derivative is x squared? X cubed over 3. Now, I know there might be a c associated with each one of these, but I'll just make it all one big c on the end. Hey, and if you're insecure, which many of you should be, but not because of your mathematical abilities. If you're insecure, just, that was a joke, by the way, take this derivative. Do you get that? Pause the video and see. You do. You get this, don't you? Right? So here, now, what do we know? We know 3 negative 1. Let's plug it in. Negative 1 equals 3 cubed over 3 plus 3 squared plus 3 plus c. Can you solve for c? Yes, you can. If you can't, drop the class. Okay. 27 over 3 is 9. 9 plus 9 is 18. 18 plus 3 is 21. Plus c minus 22. So your final answer here should be y equals x cubed over 3 plus x squared plus x minus 22. And this is the function whose derivative is this. Yes, it is. And who contains this point. And that is how we are going to solve this. Okay? This is called, believe it or not, a first order differential equation. So, this is what you're doing, man. You can do this, the antiderivative. Think about the formulas you learned for derivatives and flip them around. And that's it. It gets a little more complicated when we talk about integration, but really, let's just start off by doing some of these antiderivatives. Have a little fun with these problems and check back in next time.